Hello, and good morning. Hopefully, I get my webcam to focus here. Mr. Stevens, just checking in on our AP Chemistry homework assigned May 6th about the common ion effect and pH and solubility. You can see the notes there in the top right of what we're doing. This is on Google Classroom with the PDF provided. So the review questions 3 and 4 is really just having you guys go back in the text and your notes to see what's going on there. Questions 15, 17, again, going to your text and notes, and you can check those answers with the provided answers in the PDF. So there's more than half of your problems, basically just from using your resources to find those. And so we'll take a look at 43 here, and it's really using the common ion effect. And remember that the Rice table to work on this problem. So A is silver sulfate. We have a KSP value, and we want to find the solubility S, or you can sometimes use X, in water. So I'm going to go ahead and pause here, and I'm obviously going to set up my Rice table, so that's what I'm going to do at this point. Okay, so I set up my Rice table here, reaction, initial change, and equilibrium. Obviously the solid, we don't have anything as far as concentrations, and there is the change, but we're not going to worry about that. Obviously, it's solid. And in aqueous, we initially don't have anything, but when we add it and stir it up in water, you increase, remember, S and X are interchangeable, so try to get in the habit of the solubility. Maybe we'll just start plugging in S here. So we have plus 2S, so you get 2S at equilibrium, and then here it's just a 1 up here. I did mix up my numbers, see, I erased it. So at equilibrium, we'll have 2S, and we'll have S. And then, of course, we have to set up our equilibrium expression. I'll do that now. Okay, Rice table is good to go here in the equilibrium expression. As usual, we set it up with only the aqueous components there. Don't forget your exponents based off of the molar coefficients there, and you just plug in your equilibrium values as normal, and we get this kind of common, you'll see this coming up a lot, 4s cubed, so there's some trends in the stuff that you'll see. But then we just plug in, and of course we need to solve for S, the molar solubility. So if we divide by 4, and then we'll have to take the cubed root here, and we'll take the cubed root of this value, and then you'll get your molar solubility here for an answer. As you can see, after doing the math function there, found the answer for 43A of 1.4 times 10 to the negative 2 molar for the molar solubility of silver sulfate in just plain water. Now we are looking at 43B, which is the same problem as 43A, except with a common ion effect thrown in there, we're finding the molar solubility of silver sulfate in 0.1 molar of silver nitrate. So we set up a Rice table just the same, but this is the one difference here. Initially, the sulfate's going to be 0 because that's the same as last time. But this silver nitrate completely dissociates. At least we can assume that as much with this common ion effect. So 0.1 molar silver nitrate, it dissociates 1 for 1. So we're going to have 0.10 molar concentration there at the beginning. And then it's the same as before. Plus 2S plus S, 0.10 plus 2S, and S there. So when you use your KSP, your equilibrium expression, and try to solve for the molar solubility of silver sulfate in this problem, it does seem a little confusing here because you have a little bit of maybe tricky math. But this here is a case of a negligible X, or in this case it's in S. So in which case we do KSP equals 0.10 squared times S, and then we can solve for S from there. Okay, so just finishing up this problem here. Again, this is a case of the negligible X, or the negligible S in this case. So just disregard this here that complicates things because our KSP is so very small. Thus, you can take it out and then just go ahead and solve for it. And notice the molar solubility is less than the previously because of the common ion effect.